Good afternoon, everyone. Myself is Manasija, Bhattacharyya. I'm an assistant professor of Department of Information Technology. Today I'm giving a lecture on CPU scheduling algorithms. So I'll try to cover most of the algorithms. See, so what is the criteria of CPU scheduling algorithm? The CPU scheduling algorithm decides which of the process in the ready queue is to be allocated to the CPU. What is the ready queue? The ready queue, which processes are ready to execute, those are allocated in the ready queue, and they are served one by one according to the name. Okay. Now the criteria of best CPU scheduling algorithms, that is maximize the CPU utilization, minimize the turnaround time, waiting time, and response time. We'll go through the several algorithms and try to find out which one is the best algorithm among them. Okay. There is typical formulas are there. What is the turnaround time, waiting time, response time, relative delay, and the waiting time. This one, last waiting time, both are same. This could be calculated using the round robin algorithm specially, but we are fixed on this waiting time calculation, that is the starting time minus arrival time. For your purpose, turnaround time, the finish time is minus arrival time, waiting time, starting time minus arrival time, response time, first response and arrival, relative delay, turnaround time, that is represented in T suffix Q divided by the burst time or service time, and relative delay, this one. Same. First, we'll consider the FCFS. First come, first serve CPU scheduling algorithm. First come, first serve CPU scheduling algorithm. So this is the given chart. How many processes are there? P1, P2, P3, P4 and P5 processes are there. And their burst time means the CPU execution time. Those processes are allocated in the ready queue. They are served in these time slots, milliseconds, 5, 24, 16, 10 and 3. We need to find out the turnaround time, average waiting time and average response time calculation. So this is our target. To do that, what we need to consider the Gantt chart. So how to consider the Gantt chart? See that. So process, the number of processes are P1, P2, how many processes? 5 processes, and all are arrived at the ready queue at time 0, T0. Okay. So this Gantt chart is already given. Later we'll try to do some Gantt charts there. So the first process arrived in the ready queue at 0 and that process P1 start. What is the burst time of the P1? 5 milliseconds. So 5 is allocated here, 0 to 5 is the total process, P1 process execution is there. Similarly, for process P2 it is 24. So 24 is added with the 5 plus 24, that is 29. Similarly, 29 plus, we need to check P3s. P3s is 16. So 16 is now 45. And this 45 is added with the second one, that is the 10. P4, 10. Now it is become the 55. The last one, 55 plus, how much is there? 3. P5 is 3. So it is 58. So this is the Gantt chart, how we can prepare the Gantt chart. So it is necessary to prepare the Gantt chart before we can calculate any of the waiting time, turnaround time, response time, relative delay, all those things according to the formula. Let's check. The first, we calculate the average turnaround time. So we need to calculate the same thing for each of the process, then we can find the average. So process P1, the process P1 turnaround time, that is our formula says finish time minus arrival time. So process P1 finish time, how much process P1's finish time? This is the 5, and arrival time of all the process in this chart is given as 0. So 5 minus 0 for process P1. The turnaround time for process P2. For process P2 it is 29. So 29 minus 0, because the arrival time of all process is 0 again, so 5 and 29. See the process P3, this is 45. So finish time is 45, arrival time is 0. Process P4, finish time 55, arrival time 0, and the last process P5 is 58, so it is 58 minus 0, that is 58. So we can sum it all those things and divide it by number of processes. 5 processes are there, so we can get 38.4 milliseconds. Okay, so this is the average turnaround time for FCFS within given chart, this chart. So accordingly, similarly, we need to calculate also the other things. I'm just erasing all those things here. Average waiting time and average response time. So what is average waiting time? We have calculated the average turnaround time. Now our formula says starting time minus arrival time. The starting time of process P1 is 0 from the Gantt chart, 0, and the arrival time of process P1 again 0. So it is 0. For process P2, what is the starting time? Starting time of process P2, this one. Now, this is the starting time of process P2. Process P3 starting time 29. Process P4 starting time 45. P5 55. See that. Process P2 starting time 5. P3 starting time 29, P4 starting time 45, and P5 starting time is 55. Since the arrival time of all the processes 0, we subtract it from all the processes starting time, the 0. So we get that amount. Add all those amounts and divide it again by 5, we will get 26.8 milliseconds as an waiting time. Whose waiting time and response time will be less, that is the best CPU scheduling algorithm. The criteria says that. So in the FCFS order, we get that 26.8 milliseconds as an average waiting time. The response time is calculation is similar to the previous one, that is the waiting time. Same. The first response minus arrival. Though the formula is different, but we will get the same result. Since FCFS and SJF, we get the same result of these algorithms. Average response time. So first response again P1 0 time and it is 0. FCFS response equals to starting time. P2's 5 is the first response and 0 is the arrival time. So all the arrival time are 0, but the starting times are different. The starting time, this is the starting time of process P1. P2 starting time 5. P3 starting time 29, P4 starting time 45, P5 starting time is 55. So we subtract all those things, that is the response time, and we'll get the same result as waiting time 26.8. Okay, that is the milliseconds. We'll consider another chart for the FCFS algorithm with the given, this one is the chart. Number of processes again. How many processes? 5 processes are there. The burst times, that is the CPU execution time, 3, 6, 4, 5 and 2. We need to prepare the Gantt chart from that, and we need to calculate the average turnaround time, average waiting time, average response time. So how to calculate that Gantt chart? Let's start. The first, what is the process? Process is the P1 is the process. So process P1 arrived at time 0, so P1 execution start here. Then which process? It will last up to 3. So 3, this is the total span of process P1, 3. Then process P2. The process P2 burst time is 6, so it is 9. Process P3 process P3, 9 plus 4, 13. Process P4. Process P4 is 5. How much? It is 18. And process P5, the last one, last after 2, that is the 20. So this is the Gantt chart preparation using that FCFS order. Since all the process again arrived at time 0. Now average turned around time, that is the formula says finish time minus arrival time. So finish time, what is the process P1? Process P1, finish time how much? 3. Arrival time is 0. So it is 3. Process P2. Process P2. Process P2, what is the process P2's calculation? That's its process P2 is the, we are calculating the finish time minus arrival time. Finish time of process P2 is 9 minus 9 minus process P2's arrival time. Arrival time is again 0, so it is 9. P3 process P3's finish time is 13 minus arrival time 0. So we calculate according to that. Process P4 finish time is 18 minus arrival time 0. So it is 18. Process P5 finish time is 20, arrival time is 0. So we need to add all those things, 3 plus 9 plus 13 plus 18 plus 20 and divide it by 5. So we get the average of 12.6 millisecond turned around time. Next, the average waiting time, starting time minus arrival time. So starting time of process P1, is 0 and arrival time is again 0. So it is 0. For process P2, starting time 3 minus 0. So it is 3. P3, starting time 13 minus 0. 13. P4 starting time 18 minus 0, 18. And P5 starting time 18 minus 0, 18. Sorry, P4 starting time is 13. 0 minus 0. P2 3 minus 0, P3 9 minus 0, 9 minus 0, that is 9. P4 starting time is 13 minus 0, is 13, and P5 starting time is 18 minus 0, 18. If we add all those things, we get the result 8.6 milliseconds. Since the average response time calculation is similar to the same as the average waiting time, you will get the same result, 8.6 milliseconds. Here in this FCFS algorithm, arrival time is given. The previous example, arrival time was 0 for all the processes, but here the arrival time is in this order, is given. So we need to Gantt chart how we can construct it. For process P1, arrival time, since the arrival time of process P1 is 0, so it is 0. Brush time is 3. Construct it. P2, arrival time. Now it is 3. When it is 3, that means process P2 is already arrived in the system. So we can consider the P2 is now. So P2, how much? 6. So it is 9. P3. Next process is P3. This is the 9. That means all the process arrived in the ready queue already. So we need to there is no bother about that. So P3, same, add it to 4, that is 13. P4, how much? P4, 5, 18. And P5, 20. So we construct the Gantt chart. Now, average turnaround time, that is, we can see that 8.6. So finish time minus arrival time. Process P1 finish time is 3 and arrival time is 0. So P1 is 3. For process P2, finish time, how much? Finish time is 9 and arrival time is 3. Sorry. Arrival time is 2, that is 7. Process P3, process P3, finish time 13 minus arrival time. P3 is arrival time 4, 9. P4 finish time is 18 and arrival time of P4 is 6, that is 12. P5 finish time 20 and arrival time is 8, that is 12. So if we add 3, 7, 9, 12, 12, we get 8.6 milliseconds. That is the average turnaround time. We need to divide it by 5 because the number of processes is 5. 1, 2, 3, 4, 5. Now average waiting time calculation. Starting time minus arrival time. So what is the starting time? Let's see. Starting time again 0 for process P1 and arrival time is 0, so it is 0. For process P2, starting time is 3 and arrival time is 2, so it is 1. For process P3, starting time 9, arrival time 4, that is 5. Process P4, starting time 13 minus arrival time 6, 7. For process P5, starting time is 18 minus arrival time of process P5 is 8, that is 10. So if we add all those things and we'll get the result 4.6 milliseconds. That's the average waiting time. Average response time. Since it is FCFS, we'll get the same result in average waiting time and average response time. Here we are calculating the average relative delay, that is now different. TQ by Ts. What is TQ? That is the turnaround time and the burst time. So the turnaround time, so we need to calculate again the turnaround time for each process. The process P1 turnaround time divided by the burst time of that process. So that is turnaround time. Formula says finish time minus arrival time. So 3 minus 0, 3 divided by how much? 3. We'll get 1. For process P2, finish time minus arrival time. P2's finish time 9 minus arrival time was 2. So it is 7 by how much? 6. We'll get something 1 point something. For process P3, you'll get process P3 finish time. Process P3's finish time is 13 minus arrival time. For P3's arrival time was 4. 9 divided by P3. How much is P3? P3 is 4. For process P4, starting process P4, finish time is 18 minus is arrival time is P4's arrival time 6. 12 divided by the burst time is 5. For process P5, finish time 20 minus its arrival time is 8, that is 12 by burst time is 2. If we add all those things and divide it by 5, you will get the result 2.65. In this way you can calculate the relative delay. Now we are constructing the shortest job first. So what is the algorithm? Algorithm says shortest job first. Which process having the smallest CPU burst time among this given set, that process will get the CPU first and will execute. If there is a time means the same one. Suppose this is 24 and that was also 24. So how to break? FCFS is used to break the time. Now if I construct the Gantt chart of that process, so first which process will execute least? The P5 is the smallest CPU burst time. So P5 will execute first. Now what is the arrival time? Arrival time is common, that is 0 for all the processes. So P5 starting is 0 and it will execute it up to burst time up to 3. Okay. Next process P1, because it is the smallest CPU burst time in the list. So it is 8. Next process after P1, that is the P4 is the smallest, that is the 10. Now it is become 18. P4 done, P1 done. P3 is the next process. P3, that is the plus 16. $34. Last process is P2. 34 plus 24, that is 858. You can remove those things now. So this is the Gantt chart in FCFS order. Now how to calculate the average waiting time, average turnaround time and average response time according to the formula. See that The first one, we calculate the process P1. So process P1, we are constructing the average waiting time. Starting time minus arrival time. So process P1 starting time is 3. Process P1's arrival time is 0. Hence it is common for all the process. So it is 3. For process P2, starting time is 34 minus 0. So it is 34. For process P3, starting time is 18 minus 0. So it is 18. For process P4, starting time is 8 minus 0. 8. Process, last one, which is process P5. Starting time 0, arrival time 0. So it is 0. If we add all those things and divide it by 5, you will get 20.6 milliseconds. The turnaround time, average time, finish time minus arrival time. So the finish time, how much? Finish time for process P1. Finish time for process P1, this is the process P1. So finish time is 8 minus 0, so it is 8. For process P2, the finish time, P2's finish time is 58 minus 0, so it is 58. For process P3, finish time is 34 minus arrival time is 0, 34. For process P4, finish time is 18 minus 0, 18. For process P5, finish time is 3 minus 0, that is 3. Divided by 5, you will get the result 24.2 milliseconds average turnaround time. And average response time, first response minus arrival. See that waiting time and the response time both are same, 12.6 and 12.6, because the formula is almost same. So both the results are same in this way, 12.6. FCFS and SJ will produce the same result in average waiting time and average response time. We'll consider another CPU schedule algorithm, that is the round robin algorithm. Here the time quantum is given and the chart is given. This is the CPU burst time for all the processes and this is the time quantum. That means what? That is the process, which one is the ready queue, can execute up to 5 milliseconds, then it must release that process and another process will get the chance. So this process, process P1 will execute 5 milliseconds, P2 will execute 5 milliseconds, then P3 execute 5 milliseconds. The process will add it to the tail of the ready queue. So the process P1, all the process here again started here 0 at the time. For process P1, so process P1 start is execution and it lasts up to 5 milliseconds. Process P2 start is execution, it execute up to 5, that is 10 now. P3 up to 50. Now what will happen after that? Process P1 get the chance until its burst time is complete, it will get the chance. So process P1 again get the time quantum of 5 milliseconds and it ended up to 20 P2. Now what is the P2's remaining time? See that P2's only remaining time is 6. So is already executed 5 milliseconds, so only 1 is the remaining time. So 20 to 21, it executed 20 to 21 and P2 finished its execution. There is no P2 anymore. Now P3 is another process. P3, it gets its chance 21 to 24 because P3 is 8. So 8 minus 5, 5 is already done here in this part. So how much is remaining? 3 is remaining. So that remaining part is 3 and this is 1 is executed here. 21 to 24, that is a P3. Now 24, rest of the part, only which one is rest? 30. That is the for process P1. So P1 will continue its execution until completion. So P1 5, P1 again 5, P1 5, and P1 ended up its 30th brush time up to this 44. So this way you can prepare the Gantt chart of this round robin algorithm. Now we need to construct or consider the average waiting time, average turnaround time, and average response time. So how to calculate? Let's check. For process P1, starting time minus arrival time. So process P1 starting time is 0, arrival time is 0. So it is 0. Process P1 again start at 15. So 15 minus, what is the arrival time of process P1? Where it is left? 5. That is 5. Means 10. Process P1 starting time again 24. So 24 minus process P1 finish time, here it was 20. So it is 4. Now it is 14 for process P1 only. Similarly, for process P2, starting time minus arrival time. For P2 starting time how much? For P2 starting time is 5 and arrival time is how much? The process P2 starting time is 5 and arrival time is 0, so it is 5. For process P2 again starting time 20, arrival time 10, that is the finish time of process P2, the previous finish time 10, that is 10 here. Is there any P2? No, there is no P2, so it is 15. For process P3, starting time is 10 minus 0, that is 10. Process P3 again starting time 21, this one 21, and process P3 ended here 15, that is 6, so it is 16. So what we need to do? 14 plus 15 plus 16 will get 45 by 3, number of processes, 3 processes, you will get 15. That is the average waiting time. This is the how we can calculate the average waiting time for round robin algorithm. Now consider the average turned around time, finish time minus arrival time. So what is the finish time of process P1? For process P1 we are considering the turned around time. For process P1 finish time is 44. The process P1 finished at 44. Arrival time is 0, so it is 44. P2 finish time 21 minus 0, 21. For process P3 finish time 24 minus 0, so 24. If we add all those things divided by 3, we'll get that result, 29.67 milliseconds. The response time, first response minus arrival time for each of the process. So process P1, the first response 0, the process P1, and the arrival time again 0. So we'll get 0 as a result. The first response minus arrival time. For process
P1. For process P2, what is the first response? 5 minus arrival time 5. For process P3, what is the first response? 10. Arrival time of process P3 0. So it is 10. This is 5. So 5 plus 10, that is 15, divided by 3, that is the 5 milliseconds. So this way we can construct the round robin scheduling algorithm. One more example of the round robin scheduling. See that here the problem statement says that arrival time is given and the burst time is this one, and the time quantum is 2 milliseconds. So how to construct the Gantt chart? The rest of the process is same, the waiting time, turnaround time and average response time calculation. So first the process P1, arrival time of process P1 is 0, so we'll start here, and the time quantum is given, so 2 milliseconds. So process, we need to keep a chart of process P1, that is 9 minus 2, 7 is remaining for process P1. For process P2, what is the arrival time? Now it is already arrived in the system 2, process P2, because 0 to 2, 1 lies there. For process P2, it will again end it up to 4, and P2's burst time 5 minus 2, that is the 3 is remaining. P3. The process P3, how much? Again executed up to 2, that is the 6, and P3's burst time is 3, so 1 is remaining. P4's executed here and it is 8, so P4 is burst time 4 minus 2, that is the 2 is remaining. Now we'll get the chance again, which process? The P1 process. P1 10, 5 is remaining for process P1. P2, the process P2 will execute 2 minus 1 is remaining for process P2, that is 12. For process P3, only 1 is remaining, so it is 13. P3 completes its execution. Process P4, it is 15. Process P4, 15. P4 also completes its execution. Two of them are left, P1 and P2. Sorry, P1 is the only left. Yes. There's a 5 is left for process P1. So process P1 again get its chance. So how much is left for process P1? It was 5 is left for process P1. So 5 minus 2, 3 is. So the process P1, P2, P3, P2 completes its execution. P3 only, P3. Is it correct? P1, P2, P3, P4. Again get the P1 get this chance. I'm writing once more. Right here. So process P1 first get the chance, and 9 minus 2, that is 7 is remaining for process P1. 1. For process P2, process P2 5 is the maximum, 2 is executed, 3 is remaining for process P2. For process P3, it is 3 and 2 is already executed, that is 1 is remaining. For process P4, how much? Is 4 minus 2, 2 is remaining. Up to this. Okay. Then process P1 gets its chance again. So 2. 5 is remaining for process P1. Okay. For process P2, minus 2. 1 is remaining for process P2. P3. For process P3 only 1 is remaining, so P3 completes its execution up to here. P4 is 2 remaining, P4 completes its execution at 15. Again P1 gets its chance. So P1 last here, minus 2, 3 is remaining for process P1. After that, process P2 will get the chance and completes its execution by 1. Next, only the one process is left, that is the process P1. How much is left for process P1? That is the 3 is left for process P1. So it is 20, then it is completed by 21, process P1. So this is the Gantt chart preparation for process, each of the processes. Now, if we apply those formulas, again, average waiting time, average turnaround time and average response time, you will get the result at 9.75, 15.25 and 3.10 in this order. Okay. So I'm calculating once more to average what is the time, average, that is the waiting time, that is the starting time minus arrival time, formula is already given, starting time, arrival time, and turnaround time, finish time minus arrival time, and the brass time, that is the normalized turnaround time. The turnaround, you have already calculated the turnaround time, this turnaround time and divided by brass time, you will get the normalized turnaround time. Okay, thank you everyone. I conclude with that up to round robin schedule. Thank you.
Thank you, sir.